Hello, we're Team 18, any Surface touchscreen, and our project basically transforms any flat surface into a touchscreen for you to interface with your computer. We realized that this was something that we needed to have a embedded system for, because if I wanted to code on my computer that I need to touch something but it doesn't work, I'd have to use my hands and go to the keyboard, but no one wants to do that. So we are gonna use a LiDAR basically to figure out where our finger position is, and use a bunch of sensors like a piezo disc and an accelerometer to figure out whether we have a tap or drag and do software inputs based on that. Okay, so now we're going to demonstrate our actual project. We're going to use a stylus, and this is a debug board that we set up. And so if we take this stylus and hover it around our screen, we're going to see it track where our pointer is. And now if we want to actually click on something, you press it once, and we can see that it shows a tab. And now if you want to drag, you just tap and hold, wait for it to turn to drag, and then slowly drag it around. And so throughout all of this, it'll stay in the drag position until we let go of our
Oh, hey. Yeah, so I was working on the LiDAR. The LiDAR model is RP LiDAR A1M8, and basically this LiDAR returns the coordinate, whatever object that's nearby in polar coordinates. So you get the R and you get the theta. So you have to convert it to Cartesian XY coordinate. And then, so it lets you do a couple things with customization of the screen. So first of all, I get the X and Y size, the dimension of the screen itself. And then I also let the system take in the resolution of the screen. So whatever XY coordinates it outputs, it can be either 480 by 620 or a bigger size like 4K or 120, 80, something like that. So that's one thing. And also this LiDAR will be getting all the scans 360 degrees. So I would filter that out so it only gives the whatever object that's inside this screen or the dimension of interest.
Now, you might be wondering, how do all these components talk to each other? Alright, so first, in order to detect what gesture that we are doing, whether it's a tap, drag, or idle, we're using an accelerometer and as well as a piezo disc. So the accelerometer is the IMU that we're using in lab. It is talking to the MCU via I2C protocol, and the piezo disc, which is a type of vibration sensor, is connected to the MCU via its internal analog to digital converter. So this gets stored in the MCU in a 7-byte packet, which we then send to the XB wireless antenna via UART protocol. And then the XB then sends the data wirelessly over to our FPGA, which is connected via GPIO to the XB. And that essentially feeds our data to the monitor, and that's how we get our output.
This is the FPGA board to VGA output on here. The FPGA board, we could control the X and Y pixels. We could change it through the switches. The last half are for X and the first half is for Y. And then it also displays the resolution sizing. Let's say we want to calibrate it to this sizing. We would get the pixels here, and then we would go over to the serial monitor. And then we have to put our marker here so that we know the X min and max. On the serial monitor, we'll reset the board, and then we'll type 1 for customizing it, and then the X100s would be what showed up, 462, and then 350 for Y, and then data min and data max is the same, and the X min would be where the marker was. And then now the board is calibrated. On the board, you can see, if you put it inside the box, it should show up. And then if you put it somewhere outside of the box, it shouldn't change at all because it's not within the range.
How do we actually use this in a meaningful way? We use an ESP32 board to communicate with our laptops or whichever computer you have. Right now it's configured as a Bluetooth mouse, and basically what happens is it takes in the UART data, translates it into a software-based mouse click or a mouse move, and then does our touch screening for us for any computer that we choose.